All right, we're moving on to 10.3. We're going to apply properties of chords. So again, in section 10.1, we had a bunch of words that we defined. Today, what we're going to do is we're going to use some of those words within the problems. So you'll notice the first one says a chord is a segment with the endpoints on the circle. So that makes sense. We've seen that before. But the question is a diameter a chord? And is a radius a chord? So let's talk a little bit about diameter. If you remember from our definition with diameter, the diameter had something to do with the center of the circle. So let's say this is the center of the circle, and the diameter goes through the center of the circle. You'll notice that its endpoints are on the circle, but it goes through the center. So yes, a diameter is a chord. It's a special chord. So it's not just a chord, but it's a special type of chord, and it has to go through the center of the circle. Now the question is a radius a chord? So if you take a look back at some of our definitions, the radius said that we go from the center out to the outside of the circle. So you're going to notice that this is no, a radius is not, because it goes from the center of the circle out to the outside of the circle. And you're going to notice that its endpoints are not both on the outside of the circle, they're actually in the inside and on the outside. So the radius is not a chord. Something to be careful for, congruent chords have congruent arcs, and congruent arcs have congruent chords. And you go, well, Mrs. Medvick, what does that mean? Like, what are you talking about? What it says is that if I have congruent chords, so let's say I have a circle, and I have a chord here, and I have a chord here, and let's say these two are congruent to each other. What that means is that the arcs that they create, this one and this one, these arcs are also congruent to each other. And it also says that if I got two arcs and they're congruent to each other, then the chords are congruent to each other. And that's really important. That's going to play a role. The second thing to note is the diameter that is perpendicular to a chord bisects the chord in its arc. And you go, well, what does that mean? This is what it means. So if I have a circle, okay, and I have the diameter of the circle, and I know it's the diameter because it goes through the center, so I got to make sure I put the center in there. If I have a chord like this, okay, I know that if that diameter is perpendicular to the chord, meaning this is perpendicular, then I know that this part chord is congruent to this, and I know that this arc is congruent to this arc. So that diameter is perpendicular to the chord. It has to be perpendicular for that to occur. And we'll talk about that a little bit more as we do some problems. All right, so let's take a look at a couple of our problems. The first one is find the length of the radius. Okay, now you're going to notice that this 8 right here, this part right here, do you notice that it's not quite the radius? The reason why it's not quite the radius is I've got a little missing part down here, okay? So that is not a radius. So a radius, remember, goes from the center of the circle to the outside of the circle. That is the radius. So if I'm going to find that, what's really neat about this is you're going to notice that it created a right triangle. Here's one side of the triangle, here's the side of the triangle, and here's the hypotenuse of the triangle. So what I'm going to do is I'm going to come over here, and I'm going to go, okay, 8 squared plus 11 squared equals the radius squared. So 64 plus 121 equals the radius squared. I get 185 equals the radius squared. I'm going to square root it, and I end up with the radius equaling 9.71. Okay? So again, using the Pythagorean theorem, which is awesome. Okay? But now what do I do to find arc AB. So this now is taken a different step. So I'm going to erase what I have here, and it's asking me to find arc AB, this right here. And so I need to take a look at this whole entire thing. I'm going to go ahead and I'm going to reestablish this radius, okay? And I'm going to call angle C, this little angle right here. So I'm going to call that C, okay? And one of the things that we just learned is that the diameter, when it forms a right angle with a chord, it cuts it in half. So in other words, yes, this piece right here isn't quite a radius. It would come down, but you see how it forms that right 90-degree angle. I'm going to use that. So what that 8 does, that little piece there, it cuts this line segment in half. So I'm going to take 11, I'm going to divide it by 2, and that gives me 5.5. So this little piece right here is 5.5. Okay, so I'm going to go ahead then, and I need to find this little arc right in there. So I need to find, let's call this X. I need to call that little piece in there. So if I take that triangle out like this, I call this 5.5, I'm going to call this X, I'm going to call this 8, and I need to find X. I'm going to use some of my trig. So I'm going to go tangent of X equals opposite, which is 5.5, over the adjacent, which is 8. So opposite over adjacent. I need to find X. So what I'm going to do is I'm going to go X equals, and it's going to be the inverse tangent. If you remember finding the angle measure when we use trig. And if you do that, and you take the inverse tangent of that, you end up with 34.51. Okay, so if I do that, that's this little triangle in here. And that's that angle measure right there. Now, remember, the problem asked me to find arc AB. Well, arc AB would include 2 of those triangles because there's that central angle again. So what I'm going to do to find arc AB, I'm going to take what I found, that 34.51, and I'm going to multiply it by 2. So the measure of arc AB then ends up being 69 degrees, if I round to the nearest degree. All right. Now what I'm going to do is I'm going to go on to the next problem. And it looks kind of scary, but it really isn't. There's parts to it. And if you look at it and you look at triangles is really the key to this problem. So what I'm going to do is when I look at this problem right here, notice that I have a radius right here of 17. I'm going to draw another radius on this side right here. And I'm going to also call it 17. Right? And if I do that, you're going to notice that I have a nice little triangle that I've created right here. And I'm going to call this section right here, I'm going to call that Y. So I'm going to take that triangle out. This is 15. This is 17. This is Y. So I'm going to use my Pythagorean theorem. So I'm going to use Y squared plus 15 squared equals 17 squared. Y squared plus 225 equals 289. Y squared equals 64. I'm going to square root both sides, and Y gives me 8. Now this is important because if that little piece in there is 8, it's going to form another triangle for me, right? And the other triangle that I'm going to create is right here. Okay, this is still 17 because this is the radius. And I'm going to find this little piece right here, and I'm going to call it M. So, again, I'm going to draw that triangle. I'm going to pull it out. Okay, so I've got 17. And then you're going to notice that this little side right here, that's going to be 5 plus 8. Which gives me 13. So this is 13, and I'm going to call this M. So I got M squared plus 13 squared equals 17 squared. M squared plus 169 equals 289. M squared gives me 120. Square root it, and I get M equaling 10.95. So this M right here is 10.95. Now, if you remember, it asked me to find X, and X was a chord. If I look closely, the X is this piece right here. So, to find X, it's 2M, which is 2 times 10.95, which ends up giving me 21.9, and that would be units. Again, main idea is keep drawing triangles. Keep drawing triangles, do Pythagorean theorem, use your trigonometry, and you'll be fine. The last problem, okay, we need to find X. And if you look at it, it has a bunch of hints there down below. And again, we're going to take a look at one piece at a time. All right. So main idea is finding X. And what X is it's this little measure right in here. Okay. So the first thing that I'm going to do is I'm going to come over here. Okay. I know that this arc is congruent to this arc. And what that tells me is that if that arc is congruent to that arc, this chord is congruent to this part of the chord. So it cut it in half, and the diameter went through the center. So this is a 90-degree angle. Okay? So what I'm going to do is I need to find the angle measure, and I'm going to call this Y right in there. So I'm going to take Y plus 90. Ooh, I'm sorry. Take that back. Let's go back. I'm sorry. Because this is 57 degrees, it does. It cuts this in half, which it does because there's 2 there. This is a 90-degree angle, but also notice that there's a central angle here. This is a central angle. And this is the arc. So this angle measure right here is 57 degrees. So this is 57 degrees. Okay, so what I want to do is I want to find this angle measure here, which is Y. Okay, so I'm going to take Y plus 90 plus 57, and that equals 180 degrees. Y plus 147 equals 180 degrees. And you end up with Y equals 33 degrees. So this little piece right here, this little angle right here is 33 degrees. And that will play a role for us. Okay? All right. Let's keep going now. Because this is a radius from here to here, and this is a radius from here to here, this is an isosceles triangle. And I know that this angle measure and this angle measure are congruent. And so what I'm going to do is I'm going to call this Z. And you'll notice that this piece right here is a straight line. And so Z plus 57, come over here, Z plus 57 equals 180 degrees because it's a line. So Z gives me 123 degrees. So that little piece right in here is 123 degrees. Because that's an isosceles triangle, so this side and this side are congruent, this angle and this angle are congruent, I'm going to name those angles M. So 2M plus 123 equals 180. 2M equals 57. I'm going to divide by 2. So M is going to give me 28.5 degrees. So this angle up here is 28.5 degrees. Okay, so now what I'm going to do is I'm going to look at this larger triangle here. Okay, I don't know what X is, but I know this up here is 28.5. So I'm going to take 28.5. X is the opposite over the adjacent, and I'm going to take the tangent of it. Multiply both sides by 12. Go ahead and plug it through your calculator, and you'll end up with 6.5 units. Again, lots of triangles, Pythagorean theorem, a little bit of trig too. That is it for 10.3. If you have any questions, don't hesitate to ask.